Hi everyone, how are you? I feel great. This is a huge milestone for me. This is the first time I can see my EEG signal on computer, which means I can see my brainwaves on my computer. I already saw it on my phone using the Mind Monitor app, but this time I see it using my first ever Python project, connecting to the Mind Monitor, getting data from it, and then using Python to display the result. Let's have a look. Okay, so here it is. I have a Muse S EEG device. It has 4 channels, 2 frontal and 2 at the back, and there's some reference at the middle. And as you can see, this is just going and going and going. You can see on the y-axis the frequency, the amplitude, and on the x-axis you can see the time. So why I'm doing this? I'm currently working on a project which converts blinks to text using the Morse code. In order to do that, I have to detect eye blinks. Muse have a built-in blink detection, but it only tells whether a blink happened or not. But I have to be able to differentiate between a normal blink, a short blink, or a long blink. The short blink will consist for the dot, and the long blink will be for the line. Those are the characters in the Morse code. So, but before we do anything, let me show you a few things. How my EEG signal looks like when I'm not doing anything. You see? It's almost a normal line. Of course, there's some oscillating in it, but it's a normal line. Now, let's see what happens in case I blink. You see? There's a huge drop in the amplitude, and there's an increase in the amplitude which goes back or even more higher than the median value. Let's play a little bit. You won't believe it, but many things affects your brain waves. For example, your eye movement. You can detect eye movement based from your brain waves. Of course, you have to use multiple channels for that. We are only seeing the TP9 channel because I found this will be the appropriate one to detect eye blinks. But just look here, I will move my eyes. Have you seen it? It's very interesting, I would say. Let's see one more thing. What if I clench my jaw? You see, if high frequency signal appeared, it's very strange. Let's do it again. Amazing, I would say. At least I'm pretty amazed by brainwaves, and I just started to work with them, so I'm pretty curious where I am in a half year, a year, or even more. I think it's a very fun project what I am doing at the moment, and also what the plans I have for the future. Okay, so let's look at the eye blinks. This is a normal eye blink. You see a huge drop, then coming back, and it overshoots a little bit. Okay, then let's do a short blink. As you can see, it takes longer, it goes down the same way, but it takes much more time to come back to the normal value. So I think this will be good enough for me to detect the length, but let's see a long blink. Actually, it was a very long blink. But as you can see, it's not that obvious, but it looks like that first it goes down, it comes back to the normal value, but then there's an uprising part of it whenever when I'm opening my eyes. Let's look at it again to have a better chance to understand how it works. Okay, so it looks like it's definitely not enough to measure the time when the drop between drops going down and then coming back, because with a long blink it goes back to normal and then there's an uprising moment. So let's look at the short blink again. Okay, we have this overshooting or this uplifting part, also the short blink. So I guess we can say that there's a blink start when the brain drop and the wave drops down, and if we look at the frequency, I would say, as you see, the normal average is around 800. Actually, I use the median to be able to filter out the changes. So the median is around 800, and let's say if it goes down, it looks like it's almost always going below 800, but let's say the median minus 50, that will be which is around 750 at the moment. That will be the start of the blink. Okay, then let's check when will we say the signal has ended. Well, the normal signal, it's not that easy, because it's visible that it's overshooting, but not much. So I guess we have to say something like 820. Of course, it's a very, very simple algorithm. This is the first version. I can imagine much more sophisticated versions. I guess if I separate the signal into different frequencies, then I could use one of them or a portion of them to detect, but I don't want to use the big gun in the beginning, the Fourier transformation. So I just want to experiment with it, because I think I can make a quite good solution without going too deep into this. In the future I will definitely will, but I have a deadline now, because there's a write-a-thon which from Hashnode. It's a writing competition. You have to write an article about either mobile, web development, cloud computing, or Web3 development, and the deadline is 15th of May. And up till then I have to finish this program. I have to create a web app from it, and I have to write an article from it. So as you can see, I have a pretty short time. I only started a few days ago, but I will definitely make it somehow. But this is why I am focusing on doing only the really necessary stuff, and later I will come back and do the others. Okay, let's stop it, because it looks like my computer screen completely frozen. But that was enough, I guess. Based on that, I will be able to write the program. Bye.